Good evening, everybody. All right, so we're gonna continue with the last section of our chapter 7, and it's systems of inequalities. And so I'm gonna start off by reviewing when we used to solve last chapter systems of equations. So if you notice here, I've set up a systems of equation. So we have this equation right here and this equation right here, and they're both set equal to each other. So what we would do is we were doing just beginning of this chapter is we would graph these. Okay, so that's what we're going to do. And one way we graph. You could also do elimination, but for this we're going to graph. So I'm going to go ahead and graph this first one, and so I'm of course using y equals mx plus b, and my m is 1/3, my b is -2, so I come down to -2 and plot that. And then my slope for this one is a rise of 1 and a run to the right. 1, 2, 3. Whoops. 1, yeah, okay. And then a rise of 1 and 1, 2, 3. So there we go. So there's my line just like that. And it goes off in both directions. No big deal there. We're doing a bunch of graphing this week, as you recall, and last week actually. So now I'm going to graph the other one over here, which is y equals mx plus b. And you hear my wife clanking around in the background. I apologize for that. She's got her military boots on right now. I think she's all official. All right, so we got y equals mx plus b for the second one. In this case, my b is +1. And for this one, my slope is a negative. So that means I'm going to fall 1 and then run 1, 2. Fall 1 and run 1, 2. And there's my second line. Goes more or less like that. Of course, you guys will be using excellent graph paper, and your lines will be perfect. Okay, so no big deal. We've been doing those a ton, and if we recall, if this were solving a systems of equation, that point right there would be my solution. The difference with chapter 7.6 is not systems of equation, but it's the systems of inequality. So let's suppose that instead of them being y equals 1/3 x minus 2, it's y is greater than or equal to 1/3 x minus 2. Okay? And instead of it being y equals -1/2 x plus 2, it would be y is, let's say greater than or equal to -1/2 x plus 1. Okay, so the only difference here in the blue and the white is that I've changed it to a systems of inequality. The good news is all the work I've already done is done. I have to do that anyways. So if you remember last chapter when we had to graph inequalities like this, the very first thing we did is we changed this to an equal sign. And if you recall, I mentioned to you that I teach you one way to do stuff so that later in the book or chapters we can just repeat that. This is a perfect example. This is no big deal to us. This is going to be no big deal to us. So the very first thing we do here anyways is change to an equal sign and graph it just like we did. Change to an equal sign, graph it just like we did. So no big deal there. So now the only difference between this problem here and this problem here is we now have to test a point to see which side I need to shade. This requires shading, okay? This requires shading. So I'm going to go ahead and write that right over here. So the real problem that we are doing, and it's kind of strange that I'm doing this in blue, but in my left-hand column, I'm going to have y is greater than or equal to 1/3 x minus 2, and y is greater than or equal to -1/2 x plus 1. So this is the systems of inequality. The solution to a systems of inequality must be a graph. There's no other way to do it, and the graph has to have some shading somewhere. We've got to figure out where that shading is, and then that's going to be our solution. So we're going to do the same thing we've done before, and that was to test a point. And a great point to always test is this point right here, 0, 0. So for this first one here, I'm going to test 0 is greater than 0 minus 2. And the reason that I've just put a 0 here is because 0 times 1/3 is 0, so we should be able to do it that quickly. So then what we end up with is 0 is greater than -2, and that is true. That means that this side of my green line is true. Okay, that side of my green line is true. Now I'm going to do the same thing over here for the red line. I'm still going to test this point right here, which is 0, 0, because I can now test it for the red line. And when I plug in 0 is greater than 0 plus 1, 0 is greater than 1, that is false, which means that this point right here is false for the red line, which means that the other side of the red line is the true side, which means that the other side will be true. This side for the red is true. Now, the solution to this inequality, systems of inequality, is where the double shaded region is. This is the solution right here. So the solution is, let me get a decent color here, is above the green and to the right of the red. So see how this whole section here has double shading? It has both red and blue shading, where this section only has blue, this section only has red, and this section down here has neither blue nor red. Therefore, the only place where it's true for both is up here. What that means is that any of these points on this side make both this inequality true and that inequality true. So that's my answer. Okay? Tons of fifth color right there. You should have done tons of fifth color. Let's look at the next example. Okay, so here we have systems of inequality. We have one equation here, one inequality here. So we're going to do as we always done, and our first step is to always change to an equal sign. So I have y equals -3. So I'm going to go ahead and plot that one, and the point where y is equal to -3 is right here. And the line that goes along with that goes like this. Okay, and then I need to, I don't care what order you do it in, I'm going to do it different than I did last time. Now I'm going to go ahead and test my point to see if which side should be shaded. So I test 0, 0 right here, test this point right here in the middle. So I have 0 is greater than -3, that's true, which means this is true right here, which means for the red line it is like this. Oh, and you probably caught a mistake I just made. I can go back and correct it though, that this inequality right here doesn't have an equal sign to it, which means this line should be, hopefully you're all saying in your head or out loud so your parents can hear you, dashed. So I'm going to go ahead and change that to a dashed line by doing this. Okay, and there's my dashed line, just like that. Okay, so that's that one. Now I need to do the same thing over here for this one, and the first thing I'm going to do is change this to an equal sign. So I have 2x plus y is equal to 4. Going to subtract 2x from both sides to make it into y equals mx plus b. So I get y equals, and I don't know what I'm doing there. Let me erase all that junk. Try that again. Try to get ahead of myself. Y equals -2x plus 4. Okay, so I'm going to go and plot that one, and this time I'm noticing right off the bat this is equal to, therefore it's going to be a solid line. So I go up 4 to right there, and then it's -2, so it's a fall of 2, run of 1. Fall of 2, run of 1. So there's my new line. Whoops, that's a terrible line. Go ahead and try that again. And so there's my line right there. And then my last thing I need to do is I need to test a point. So I'm going to test, of course, I love to test 0, 0. It makes it nice and easy. So I'm going to test this point right here. That's the point that I'm testing. And so I'm going to test this point right here. Okay, that's the point I'm testing right there. So I'm going to plug in 0 here, and then I go back. Let me change that real quick, or remind you that I always refer back to the original inequality. So when I plug in 0, 0, I don't plug it into this one right here. I plug it into this one right here, the white one. I go back to the original inequality. So I'm going to have 0 plus 0 is greater than or equal to 4. And this 0 here comes from the 2 times 0, which would be 0. And this here is 0 because y is equal to 0, so that's that one. So then, of course, 0 is greater than 4 is false, which means that this is false right here. And so if this side is false here, if this side here is false, that means that this side of the line must be true. So then my shading would be on this side of my line, which means that the solution to my problem is right here. This side right here above the dashed line and to the right of the blue line. So all of this section right here, make sure you say it clearly. I know I'm kind of scribbling. Make sure you say it clearly where the solution is. I'm trying to make it clear for you so that you can see that this is not the solution, this is not, nor is this. Okay? All right, so that's it. That's the notes for tonight. Not too long. 2 basic questions. You guys know how to do it all already. It's a matter of just putting some stuff together and applying it in a new way. All right, I will see you guys tomorrow.